Alright guys, so what we're going to be doing today is we're going to be taking those trig functions that we learned recently, and we're actually going to be looking at the inverse graphs of those trig functions. So if you guys remember, in order to find an inverse, we did that in Algebra 2. The way you find an inverse is you switch the x and y coordinates. And then that would give us our inverse graph. So like a basic example, let's say I had the function y equals x cubed. If I wanted to find the inverse of that, the inverse would be x equals y cubed, but then I'd have to solve for y in order to graph it. So to get y by itself, I would take the cube root. So the inverse would be y equals the cube root of x. And those functions would be reflections of each other over the line y equals x. So the way I do that with my trig functions, I still do it in a similar way. I still need to switch my x and my y coordinate. And when I do that, I would get the function x equals the sine of y. So now I need to solve for y. Now I can't just divide by y though, because I'm actually taking the sine of y. So if you guys remember, like when I had the calculator questions, that was like something like 0.374 is equal to the sine of theta. The way you had to get theta by itself, you had to, on your calculator, you're looking for an angle, you had to use secant, so you had to use the inverse function. So the way we're actually going to do this, in order to get y by itself here, is we're going to take the inverse, using that inverse function, and that would be written as y equals sine inverse of x. So that's my inverse function I'm going to look at. So in order to figure out what this graph's going to look like, is I'm going to plug in a few values to the normal y equals sine of x function. So I'm going to make just a little xy chart for this graph that we've already looked at. So I'm going to pick a couple of y values that we've used before. So we'll do 0, we'll do pi over 2, pi, 3 pi over 2, we'll do 2 pi, we'll do negative pi over 2, and we'll do negative pi. So if I plug these values into that y equals sine of x function, the sine of 0 gives me a value of 0. The sine of pi over 2 is 1. The sine of pi is 0. Sine of 3 pi over 2 is negative 1. The sine of 2 pi is 0. The sine of negative pi over 2 is the same as the sine of 3 pi over 2, so that's negative 1. And then the sine of negative pi is the same as the sine of pi, so that one is also 0. So this gives us a few points on our graph that we would plot if we were doing y equals sine of x. But because we're doing the inverse, we're going to look at the graph of y equals sine inverse of x. And the easiest way to find an inverse is just to switch my x and y's. So I'm going to take that chart I already have, and I'm just going to switch the x and y's. So 0, 0 is still a point. However, instead of pi over 2, comma 1, the point I'm going to plot is 1, comma pi over 2. So I am just switching the x and y values. And those are the points I'm going to plot on my graph. Alright, so on my graph, I'm going to actually go ahead and make these. So if you look, really the only x values we have are negative 1, 0, and 1. And I'm going to go ahead and graph these points. Alright, so I went ahead and plotted those points, and now I'm going to connect those. And if you guys remember, this is still a wave, just like my sine was. So I'm going to connect these in the same way. Now the problem here, if you guys think back to Algebra 2, you learned about something called the vertical line test. And the vertical line test helped us see if something was a function. And the way that worked is if I draw a vertical line anywhere on my graph, if it touches more than one place, then that function can't be a function. So this graph obviously is not a function because there are several places, that wasn't really vertical, but there are several places I could draw a vertical line and it touches more than one place in my graph. So in order to make this graph a function, we need to do something called restricting the range. Okay, so we are going to restrict the range. And what that means is we're just going to look at a certain area of y values that is going to make this graph actually be a function. And we're going to talk a little bit about why we pick the restrictive ranges that we do on Monday. So what the range we're going to look at is actually just from negative pi over 2 up to pi over 2. So if I only count that small little curve right there, now this graph's going to be a function. So what I'm going to do is I'm just going to erase the rest of this graph. So I'm only looking at that section now. All right. So if you guys look, there are 3 main points on this graph. So I have a restricted range from negative pi over 2 to pi over 2. And there are 3 points here that I'm really going to need to know because we're going to do transformations in these graphs next week. So those 3 points I really have are 1, pi over 2. I've got 0, 0. And I have negative 1, negative pi over 2. And those are the critical points. So those are the points that I'll actually be doing transformations to next week. All right, so we're going to look at the rest of the parent functions for all of these inverses, and then the first one we're going to look at is going to be cosine inverse. So in order to do cosine inverse, I'm going to go ahead and let you know what the restricted range is. Again, we're talking more about why this is in class, the next class. So my restricted range for cosine inverse is going to be actually from 0 to pi. So I'm only going to be looking at y values from 0 up to pi. So I'm going to think about some basic points for the function y equals cosine of x that I could actually flip for this graph. So for the y equals cosine x, if I plug in an x value of 0, the cosine of 0 is 1. If I plug in the x value of pi over 2, the cosine of pi over 2 is 0, and then if I plugged in pi, the cosine of pi is negative 1. So all those x values fall in my restricted range. So when I go ahead and flip these, those are going to be my inverse values. So all I'm going to do is I'm going to switch my x and my y's, and I'm going to make those points on my graph. So the critical points I'm going to be plotting here, or instead of 0, 1, I'm going to be plotting the point 1, 0. Instead of pi over 2, 0, I'm going to do 0, pi over 2. And I'm going to plot the point negative 1, pi. Okay, so I have those critical points plotted, so now I'm just going to draw my graph. And if you remember, this is part of a curve, so I'm not just going to connect them in a straight line. It's part of a curve that would continue. So my graph's going to look a little something like that. So that is my cosine inverse parent function. So yeah, what you guys need to know about this is I need to look at the restricted range, and I'm going to need to know the critical points for when I do my transformations. All right, the next two we're going to look at are going to be tangent and cotangent. So again, we're going to start with our restricted range. So our restricted range for tangent is actually going to be from negative pi over 2 to pi over 2. But the difference with this, if you guys think back to y equals the tangent of x, if I plug in the x value of pi over 2 or negative pi over 2, the tangent of pi over 2 is actually undefined. So what that means is that those 2 points I'm actually not going to touch. Those 2 points on my graph are actually going to be asymptotes. So pi over 2 and negative pi over 2 will actually be asymptotes on my graph. So to get my other critical points, again, I'm going to think about y equals tangent of x. Y equals the tangent of x. If I plug in the point 0, the tangent of 0 is 0. If I plug in 1, the tangent of 1, giving you the answer already. If I plug in pi over 4, the tangent of pi over 4 is 1. Or if I pick, again, another point in that restricted range would be negative pi over 4, and the tangent of negative pi over 4 is negative 1. So the inverse is going to be the inverse of these points right here. I'm going to take my x and y's, and I'm going to flip them. So I'm going to flip my x and y's for all of these to get my critical points. So I'll flip those, and then I'm going to plot those points. Okay, so those are my critical points of my inverse function. I just took that y equals tangent of x and just flipped my x and y's. So I'm going to plot those critical points on this graph. So I've got 0, 0, negative, all right, so I'm going to plot those points. So I have a point at 0, 0. I've got a point at 1 pi over 4. And I've got a point at negative 1, negative pi over 4. And then remember, because the tangent of pi over 2 is undefined, there's an asymptote there, and there's an asymptote down at negative pi over 2. So what this graph's going to do is it's going to look something like that. So it looks similar to the tangent function, but again, this is the inverse. All right, so let's do cotangent now. So cotangent is going to be similar, but a little bit different. So my cotangent function is going to have a restricted range of 0 to pi. And again, it's going to be in parentheses because I'm going to have asymptotes at those two places because the cotangent of 0 is undefined and the cotangent of pi is undefined. So at 0, there's an asymptote, and at pi, there's an asymptote. So then just to fill in those points in between, I'm going to fill in those points. I've got pi over 4, pi over 2, and 3 pi over 4. And I know back from what we did with those other functions, I know that the cotangent of pi over 4 is 1. So that's a point. The cotangent of pi over 2 is 0, and the cotangent of negative 1 is 3 pi over 4. So the cotangent inverse graph is going to look like this. And my three critical points are 0, pi over 2, negative 1, 3 pi over 4, and 1 pi over 4. Now one thing I do want to add for both these graphs to the critical points is I do want to add the asymptotes. So let's just remember that this graph also has horizontal asymptotes at x equals 0 and x equals pi. And then my previous graph, y equals tangent of x, had horizontal asymptotes at x equals negative pi over 2 and x equals positive pi over 2. So whenever I graph those, I'll actually need to include them. All right, the last two we're going to look at are going to be secant and cosecant. So my secant and cosecant graphs are going to have a restricted range that was similar to my previous graphs. So the restricted range for cosecant is going to be the same as it was for sine, because cosecant and sine are reciprocals. So that restricted range is from negative pi over 2 to pi over 2. And if you think back, okay, to regular old y equals cosecant of x, some points that I would have plotted, I'm just going to flip the x's and the y's. So instead of plotting the point pi over 2 comma 1, I'm going to plot the point 1 pi over 2. So that is one of my critical points, because the cosecant of pi over 2 is 1. Another point I would plot that's in that restricted range, if I go down to negative pi over 2, the cosecant of negative pi over 2 is negative 1. So that's one of my critical points. All right, and then another critical point actually that I'm going to need to plot would be an asymptote. Because if I were to plug in 0 here, 0 falls in that restricted range, but the sine of 0 was 0, which means that the cosecant of 0 is actually undefined, which means that x equals 0 is going to be an asymptote, a horizontal asymptote. So this graph is going to look a little different. So I'm going to plot those points that I know. I've got 1 pi over 2. I've got negative 1, negative pi over 2. And then there is a horizontal asymptote at 0. And then just like usual, this graph is going to actually approach that asymptote. So my graph is going to look a little bit different. It's going to look like that. All right, the last one is secant inverse. So secant inverse has a restricted range, just like cosine, because secant and cosine are reciprocals, not inverses, but reciprocals. So my restricted range here is going to be from 0 to pi. And my critical points I'm going to plot are going to be -1 pi, 1, 0, and this one is going to have a horizontal asymptote at pi over 2. So secant inverse is going to have an asymptote at pi over 2. And then let me plot those other points. So I know that the cosine of 0 is 1, so that means that the secant of 0 is also going to be 1. So this graph is going to have a point down here, and my graph is going to go towards my asymptote. Then I know that the cosecant of the cosecant of pi is a -1, so that means that -1 pi is also going to be a point, and it's going to go towards my asymptote. So that's what my secant inverse graph looks like. All right, so the biggest things on these guys to learn is just going to be to know these parent functions, especially sine, cosine, and tangent. Those are the most important ones to be familiar with. And we're going to look at these a little bit more on Monday.